The next part is we still have inequalities, but this time we're going to have compound inequalities or absolute value inequalities. And we're going to start off with a compound inequality of something along these lines. And when it's written like this, it is an intersection. Um, so when we solve intersections, as a reminder, when it comes to graphing it on a number line, the graph will always come together. So I know I'm going to have open circles on my graph because of the symbol, okay, strictly less than and greater than. Now, when you read this inequality, it's going to, again, just like we did with the single inequalities, you always have to start with the variable. Well, my variable is in the middle. So the reason why we call this a compound inequality is because there's really two. So when I do my two-step to get v by itself, I have to do it to all three parts. Because then this is my 0, and 2v plus 0 is 2v. So I'm just trying to get this down to 1v. So I'm going to divide by 2. Keep in mind, this would still take into effect, if you ever had to divide by -2 here, you would have to change both of these signs. So in this case, now I have my two numbers, 10 and 6. All right, now when I read this though, all right, I'm going to color code it. You got this one, which you would read left to right, and that would be less than, because you come to the point first. So that's why I'm going to go this direction. Now if it was this one, I'm going to read it right to left. So I'm going to read it this way, and I come to the opening first, which is greater than 6, which means I go this way. Another way to cheat with intersections is that the number line always comes together. Okay, this would also be equivalent. If you wanted to split it up, you can write v is less than 10 and v is greater than 6. The key is that I had to flip that sign right there because I put the variable v on the left side, so I still wanted to say a greater than symbol. Okay, but there's your single, the only compound inequality that you have. The next two have an absolute value. And the key with the absolute value is understand, okay, how do I rewrite it? Okay, it's all about the sign. If it's a greater than symbol, it is, the fact that that's a greater than symbol tells you that you have a union. And the easiest way to remember about this is that unions have the word or in between it. Okay, intersections have the word and, like it is over there. But now the first one stays the exact same. All right, so you just drop the absolute value sign. All right, so I'll just put a little quote here. All right, that's the pattern that you need to memorize. Now the next one, you have to put this in a different color. You drop the absolute value, but the sign has to flip. So flip and make it negative. And I'll put NEG for negative. So, and then you just solve each one of those separately. Now, it's going on the graph. It's going to do the complete opposite as intersections. It's going to go in two separate directions. Again, I'm adding 4 to both sides and dividing by 3. Okay, and then I just bring down that or. So if I read both of these, I have, so if this is 0, here's -2, here's -1. All right, so here I'm reading it left to right. I come to the point first, less than -2, so it's open because it doesn't have an equal to. So less than -2 is that way. 14 thirds, 3 goes into 14 4 times with, because 4 is 12, so you have 2 remaining. So a little shy of 5. 1, 2, 3, 4, 5. And then again, that's an open circle. It's not at 5. 4 2/3, so a little bit shy of 5. And it would be to the right because this is a greater than symbol. You're going to be opening first. And the unions always go in separate directions. So the next one is an intersection. So number 19 will be an intersection. Okay, and it would be something like this. You'd have -9n -3. Then here my symbol will be a less than. So since it's less than, Okay, that is going to be an intersection. So we want to rewrite this as number 17. So we want to make it look like this. So then we can just solve it just like we did there. Now, how do we do that? Well, it's quite simple. The sign of the negative 15 will go on the left. So I'll color code that. All right, so whatever number is here, you put on the left side and make it negative. So that's really the only thing you have to remember. Everything else you just copy. So the symbol, the expression, the symbol, and the positive. You just copy the rest of it now. The symbol will stay the same. And now we just solve it like we did in 17. All right, so we add 3, all right, to everything. All right, just do the 2 steps here. And then when I divide by -9, you're going to have to flip the sign. All right, so key point of emphasis here, just like we did with single inequalities, that sign has to flip because you are dividing by a -9. Now, here we have -2. Here we have 1 4/9. All right, it's positive because you have 2 negatives. So 9 goes into 12 one time with 4 remaining. So now that's in between, right? Like we can always cheat too when it comes to the graph, as far as it's always got to be coming together. So if I read it one at a time, I'll do this one. That's going to be greater than -2. All right, always start with the variable. So n is greater than -2. So I have an open circle, and I'm going to do this in green to color code it. So greater than would be to the right. Now 1 4/9. Okay, if I read that one, all right, you don't, again, start reading it with the variable. So n is less than 1 4/9. So a little shy of 2. And then probably not even, it's actually probably right around there. And less than, so it comes together. And we knew that because it was an intersection.